We are graphing systems of inequalities today. We are going to finish the slides. So let's insert some text boxes here. Going to zoom in. And we are going to talk about systems of inequalities. So remember, with systems of equations, that meant we had two or more equations, right? That were graphed on the same plane. So a system of linear inequalities would be two or more inequalities graphed on the same plane. So let's go back over here. Do a little text box. I'm going to make mine about 24. Okay, so the steps are, number one, solve each inequality for y. Get it in the slope-intercept form. Step two is going to be graph the first inequality. Step three, graph the second inequality. Step four is the solution set is the intersection of the two shaded areas. Okay, don't forget to dash the line for greater than and less than. A lot of people forget the dashing part of it. Remember, the dashed part is not part of the solution. Solution set, intersection, or let's say area where it is shaded 2 times. 2 or more times, I guess, if we're doing more. And then a no solution set is when there is not an intersection of the shaded areas. Sometimes they're shaded in opposite directions and their shading never intersects. There we go. All right, so we are going to shade or do 3 examples on our digital notebook, and then we'll do a couple in our journal. So let's go over here. And we're given points and some lines that we can use. If there is a solution set, place the solution set box below in the area where the shaded of both inequalities will overlap on the graph. If there is no solution set, place that box on the graph. Okay, so we have 2 equations. So step 1 is to solve both of them for y. So I'm going to do this in my composition book. So open up your composition book. and title it Graphing Systems of Inequalities. Slides 14, 15? Yeah. So we need to solve each one for y. So do it just like we solve equations. So minus 2x on both sides. Y greater than or equal to negative 2x plus 1. And the other one, subtract x on both sides. Negative y greater than or equal to negative x minus 2. And then we need to get rid of this negative, so we're going to divide by a negative 1. What do we need to remember anytime we divide by negative? Yeah, flip this sign. So it's now y is less than or equal to negative over negative becomes positive. X over 1 is just x. Negative 2 over negative 1, just positive 2. So we have our two inequalities solved for y. So now let's go back over and graph it. Well, we need to write what our M and B are here. So on equation 1, our M is negative 2, and our B is positive 1. So let's graph it. So in order to graph it, plot a point at your y-intercept, positive 1. So I'm just going to do the first one first. And then our slope is negative 2. So go down 2 over 1. Find another point, down 2 over 1. Down 2 over 1. So we need to do, what kind of symbol is that? Solid line. And then how are we going to shade? Above or below? Above, because it's greater. So we need a solid line. There we go. And shade it above. So when we shade on here, we are going to use two different shadings. Do y'all remember how to shade? Remember that polyline? So you go to polyline and then start at the bottom of your arrow, slide over, click, slide up, click, back to the arrow, and then slide down to your original. Yep, it is supposed to be above. So we start there. There we go. shade above, and then do one of your custom colors that has the transparency. I'm gonna do my blue. Transparency should be right around the middle whenever you change your color, so we can see through it. Let me fix that. There we go. So change your color and change the transparency. Okay, let's go back over here so we can look back. What is the slope and our y-intercept? So the slope is 1, our y-intercept is 2. And then how are we going to shade this if it's a less than or equal to? The or equal to is telling us it's solid. And the less than means below. So plot a point at +2. And then your slope is up 2/1. And then down to left 1. Down to left 1. And we need a line, so I'm going to copy and paste that line and redo it. Okay, do y'all agree with that? No? What's wrong with it? What did I do wrong? Yep, up 1/1. Down 1, left 1. So it's a positive slope of 1. Okay. There we go. Is that okay? Okay. And now you'll shade it and use a different color to shade it. Do the polyline. And below would be down here now. I'm going to change my color. And what I like about doing it on the computer is whenever you shade it, you see that the mix of the two colors, this kind of teal color and this pink color, mixed together to make the purple. So that's our solution set. So we're going to drag this over to there, and that's our solution set. Oh no. I don't like how that looks. So I'm going to change this to white and this to black. And maybe bring it to front. There we go. So where they intersect, where the two shadings cover each other and it makes a different color, that is your solution set. So whenever you do it on paper, you can actually do it with highlighter or with colored pencil, or I'll show you how to do it with just a regular pencil. You could just do different kinds of shading. Like one of them you can go like that diagonal, the other one you can go like that diagonal, and where you have it shaded twice, like different diagonals, that's where would be your solution set. So this is our solution set. So anything within this area and also on the line, because it is a solid line. Okay, let's go on to slide 15. Let's go to the left side. These are already solved for y, making it a little bit easier. And they didn't give us these, so we'll have to use this. All right, so we want to first solve for y. It's already done. So now write our slope and our y-intercept. So our slope on the first one is 2. Our y-intercept is 3. We need some points, so come over here. Grab some of these points, Control C, Control V. And you can take some of the points over here. Just to help you. Okay, so we have y-intercept at 3 and our slope at 2. Slope 2 over 1, down 2 over 1, down 2 over 1. And then is this solid or dashed? They're both solid. Okay, and this is a less than symbol, so it's going to be shaded below. So remember how I taught y'all airplane arms? You stick your arms out. Anything below your arms, whenever you tilt your arms, is considered the less than. That would be where your feet are. And then anything above where your head is would be the greater than. So this is a less than. So if I stick my arms out just like this, the less than is over here. So do the shading. And use one of your custom colors that has the transparency. And then the other one, our slope on the other one is 2, and our y-intercept is -1. So we would start at -1, up 2 over 1, up 2 over 1, and then go down to left 1. We need another solid line. These have the same exact slope, so they're parallel, but that doesn't mean they have a no solution. Because this one's a greater than symbol, so we're going to shade above on this one. So here's the line. To shade above, we would go on this side. And so our solution set is right here in between the two lines. So I'm going to take this, put this over the solution set. I don't like how it looks, so I'm going to change it to black, change this to white, and then I'm going to turn it sideways, scrunch it in, and bring it to the front. Send that one to the back. Okay, there we go. Which this really doesn't even need to, let's see. There we go. You can even change it to that so that you can just see the color. And so that's our solution set in between those two lines. I just did formatting. It really doesn't matter. Just as long as you know in between the two lines is your solution set. You might have to send these others to the back because once you put it over here, you can't move it. So if you select the transparent or the shading part, right click and go order, and you can send it to back or bring it to front. So it's just some little formatting things that you got to do. Okay, let's look at the last one. 5x minus 2y is less than 6, and then y is less than negative x plus 1. So we are going to have to solve that first one for y. So let's write it down. So this is actually the third equation, or the third set of equations. So we have 5x minus 2y is less than 6. Minus 5x minus 5x. Negative 2y is less than negative 5x plus 6. So divide by the negative 2. So y is less than negative over negative becomes positive 5 over 2x. Oh, but we've got to change this, don't we? So I need to change it. Y is now greater than 5 over 2x minus 3. Do y'all agree? Is that okay? Did I do it right? Less than becomes greater than because we divide by the negative 2. Okay, so is this going to be dashed or solid? Dashed. And then how are we going to shade? Okay, so we need a point. Oh, we need to write our slope and our y-intercept. So on this one, our slope is 5 over 2. And our y-intercept is negative 3. So we'll start at the negative 3. And then we'll go up 5. So 1, 2, 3, 4, 5 over 2. It's a dotted line. I can grab the one over here. Or, yeah, I'll go ahead and grab that one. Pull it over here. I know I'm going to need another one because the other one is also less, not or equal to. So here is the line. Okay, it's going to be shaded above So this is the above area. The other one's already solved for y. So our slope is -1 and our y-intercept is 1. So we are going to plot our point at 1 and then go down 1 over 1, down 1 over 1, down 1 over 1. And it's dashed. So let's there we go. That's about right. Yeah. And we are going to shade, it's a greater than, so we're going to shade above. So above would be up here. And so we do have a solution set right here. I'm just going to make a text box and put over here solution set. There we go.
Your solution set isn't.
So yeah, the only thing that's important on this is the solution where they intersect. But remember, these are dotted lines, so anything on the dashed line is not included. Only thing is in between here. So we don't care about, this would be called like the inverse because it's the opposite of, because if you were to shade them opposite, that's what would be shaded. We don't care about anything that like that. We only care about where it's overlapping. All right, so in your journal, we're going to do one more. So let's see. This is going to be 2x plus y is less than -1, and 2x plus y is greater than 3. So we need to solve both of them. Y is less than -2x minus 1. So our M is -2. Our B is -1. So we're going to do it by hand on this one. So this would be -1 And then down 2 over 1. Oh, gosh. And this one's going to be dashed. And then less than means shade below. So where is below on this one? Left or right part? Yeah, it's left. Okay, the next one, minus 2x, minus 2x. Y is greater than negative 2x plus 3. So our M on this one's negative 2. Our B is 3. Go ahead and graph that. So this one's also dashed. And it doesn't have to be that they're both the same because they could be different. It just happened on this one. Shading above because it's greater than. So then this one, there is no overlapping area, so this is a no solution. Okay, I want you to do this one. Now, this is our last one. I think I said that last time, I'm sorry. But this really is. So the first one has a slope of 0 and a y-intercept of 3. So what kind of line will that be? Look to the left of, remember Hoy and Bucks? Hoy means horizontal line, 0 slope, y equals the number. So it's a horizontal line at 3. And it's solid. So before you slide that line across, make sure you know solid or dashed. Okay, and then this is a less than. So how are we going to shade? Below. Okay, and then the next one we have a plus 2. Our y-intercept is 2, and our slope is 1. So plot at 2, and then go up 1 over 1. But this one is dashed because it doesn't have the or equal to. And how are we going to shade this one? above. So see how I did this one back and forth horizontal lines? So the other one, I'm going to go up and down so I can see where is it, the cross. Where does it cross? So this is where it was shaded both ways. So this is your solution set. All right, that is all. Tomorrow you'll have an